So starting today, we're going to learn graphing. So this is where you got to pay extra attention because the graphing part is kind of the hardest part of this chapter. Okay, so the parent function we're learning in this chapter is called the reciprocal function. So reciprocal means something over something. So this is going to be the 1 over x function. Okay, so since this is a new function we have not seen yet, let's go ahead and graph it by just picking numbers. So let's start from, let's put more numbers in this time because without a lot of numbers, it's kind of hard to see the shape. So let's start at -3, -2, -1, 0, 1, 2, 3. Okay, so all those x values are going to go into 1 over x. So if I put in -3 in 1 over x, what do I get? -1/3. If I put -2 in there, I get -1/2, and then I put -1, -1. If I put 0, 0? Nothing. Okay, I can't divide by 0. So something is going on at 0. I put in 1, 1, and then 2, 1/2, and 3 is 1/3. All right, so now I graph these points. -3, -1/3, whoops, negative. -2, -1/2, -1, -1. 0, nothing goes on. 1, 1, 2, 1/2, 3, 1/3. So like that. You can put in more points, but you're going to see that the graph is going to curve. Bless you. So the graph basically curves like this, and it never is going to reach 0 because at 0 it's undefined. Yeah. And then on the right-hand side is the same thing. So it never reaches 0 on the x-axis, kind of like when we did the exponential function. And then also it never reaches 0 here. So like the last chapter, we're going to have asymptotes. But this time, there are 2 asymptotes. There is definitely one at x equals 0 because this is where the domain is undefined. So when the denominator is undefined, there is something going on. At the same time, there is something going on here as well in the horizontal. So yes, at 0. And so in this graph, there are 2 asymptotes, one vertical and one horizontal. All right, now let's look at the parent function. So the very general function of 1 over x with all its transformation is like this. So kind of take a look at how it looks like. So the 1 over x is kind of stuck here. It's kind of invisible, but it's kind of hidden there. And you can see that a is being multiplied to 1 over x. H is moving left and right next to x. Okay, it's right next to x inside the function. K is totally outside. Okay, so don't get H and K confused. Those two are very easily confused because it's not kind of in the normal way we see this. Okay, so now let's go ahead and redefine some of these. X-intercept is when what happens? Yes, y equals 0. And y-intercept is when x equals 0. Domain means what? The values for good. Or we can say, what does the denominator not equal to? So we've talked about this for about a week now, right? What does the denominator not equal to? That's the domain problem. Okay, so what you're going to do is just remind yourself to set the denominator to 0 and then solve for x. Okay, range means values for y, good. All right, vertical asymptote. Vertical asymptote is the vertical line that the graph cannot cross. And that is usually the Not the y-axis, the domain restriction. So whenever they say, what is the domain restriction? Basically, what does x not equal to? Usually that is going to be your vertical asymptote. And I say usually because there are exceptions, and we're going to talk about that like the next 3 days. Horizontal asymptote is the horizontal line that the graph cannot cross. And I want to say usually. Oh, I think I spelled that wrong. No, did I? No. Oh, did I spell it wrong?
No.
Oh.
Yeah, it looks weird with like
Yeah, with capital letters, yeah. So usually it cannot cross because in the next 3 days we're going to look at very weird graphs. Sometimes it does cross. Okay, so these are vocabs you got to remember. So every single graph we do, we're going to do all of them and more. So every day we kind of add on until we can analyze every single graph with all those things. All right, let's start with the first one. Okay, so look at this graph or this equation. What is the parent function? Parent function means the original function. Oh, no. 1 over x. Yes, 1 over x. So 1 is kind of stuck in here. So let's look at the transformation. What are some things we did to this graph? Yes?
Stretch 8.
Yes. Okay, so this 8 is being multiplied. So remember that is going to be your stretch. Okay, so stretch 8. Okay, what else? Right 1, very good. Right 1, not down 1. Up 2, very good. Okay, so we're going to take the original graph. Okay, the original graph, you kind of have to remember, it looks like this. The right side goes up, left side kind of goes down like this. First and third quadrant. We're going to stretch 8, so it's going to be pulled more vertically. Right 1, up 2. Okay, right 1, up 2. That means your asymptotes are going to shift. Where are the asymptotes in the original graph? 0 and 0, right? X equals 0, y equals 0. Now we're shifting them, okay? So sometimes it's much easier if we just start analyzing these before we start graphing. Okay, so first, let's just look at the domain. What does x not equal to? 1. Okay, that's in the denominator, so that's a problem. We'll talk about range later. Okay, next, let's look at your asymptotes. Your vertical asymptote and your horizontal asymptote. Vertical asymptote is basically where x is not equal to. So where is the vertical asymptote? 1, correct. Okay, and then also another way to think about it is you take your graph and you move to right 1. So it was at x equals 0, and now it's moved to the right 1, so it's x equals 1. You also move the graph up 2, so where is the horizontal asymptote?
2.
Yes, y equals 2. Okay, so it's much easier if you just start graphing those lines first. All right, it's going to stretch 8, so it's going to pull it up a lot. There's no reflect over x-axis, so probably going to still be in the first and third quadrant like that. But we do want to get a little bit more information so we can graph it better. Let's do the x-intercept. Actually, y-intercept first. Y-intercept is easier. Y-intercept is when what happens? X equals 0. So we're going to solve it with x equals 0. So 8 over 0 plus 1 minus 2. Oh, is it minus 1? Sorry. Minus 1 plus 2? Oh, sorry. Okay, so where is the y-intercept? -6. Okay, so is that right? Okay, so 0, -6, there is a y-intercept. So just put that point in there, 0, -6. X-intercept. X-intercept is when what happens? Bless you. Y equals 0. So 0 equals 8 over x minus 1 plus 2. It's a little bit trickier to solve this, but it's actually not that bad. It's just that when you first see it, you might get a little panic, like, oh, how do I solve this? All right, so just kind of take out your math sense. What should you do first? Subtract 2. 8 over x minus 1. What's the next thing? Times x minus 1. Make sure you put in parentheses. And then what? Oh, don't distribute. Divide by -2. X minus 1 equals minus 4. And then the last thing? Add 1. So x equals minus 3. So there is another point at -3, 0. Okay, unless you want the graph to be super accurate, I would say these are enough points to see how the graph looks like. So the graph is definitely going to go through these 2 points. And the other side, just kind of randomly draw that. And then you're done. We don't really need it to be super accurate. We just want to know where the specific points are. The x-intercept, the y-intercept, the asymptotes. Yeah.
That's how it's going to be on the homework and test.
Yes. Mm-hmm.
So
Yeah.
like half.
Yes. Okay, and then so vertical asymptote. Okay, so x equals 1. Horizontal asymptote is y equals 2. All right. Do you think you can do these on your own? Or you want to try it? Yes, question.
Where did you know how to the top right quadrant?
Because it is the transformation of the original graph. The original graph is 1 over x, which looks like this. This is just going to move it around. So once I know how one side looks like, I can know that it's going to be the diagonal on the other one. Yeah.
Can we do range?
Oh, sorry. Yes. What is the range of this graph? So another thing to kind of ask yourself is, what can y not be?
0.
No, y can't be 0 because it's crossing at here. That's 0 for y. Yeah?
Y is greater than 2, y is less than 2.
Yes. Okay, y is greater than 2 and y is less than 2. Or what's another way to say it? Yes, y cannot be 2. So basically, it's going to be the horizontal asymptote. Okay, so domain is usually just the vertical asymptote. Range is usually the horizontal asymptote. Okay, let's do one more before I let you. Huh?
Domain is usually which asymptote?
The vertical asymptote, right here. Usually the vertical asymptote, and then range is usually the horizontal asymptote. I say usually because we're doing the easiest section right now. When we start doing other graphs, it gets really complicated. Okay. All right, next one. Let's try this one together. Okay, what is the parent function again? Let's see. 1 over x. What is the transformation? Left 1, and then down 2. Okay, so this one's pretty easy. There are only 2 transformations. And like I said, it's much easier if we just analyze the whole thing before we start graphing. What is the domain? X cannot equal -1. Can you guess where the range is?
Y can't equal -2.
Good. Okay, so then it's much easier if we just go straight down to vertical and horizontal asymptote. So where's the vertical asymptote?
X equals -1.
Yes, and then horizontal asymptote is?
Y equals -2.
Good. All right, let's try solving x and y intercept. Those are the tricky ones. Y-intercept is very easy to solve, so let's do that first. Y-intercept was when what happens?
X equals 0.
X equals 0. So y equals 1 over 0 plus 1 minus 2. So that is
Y equals
-1. Okay. So we have a point at 0, -1. All right, x-intercept is when what happens? Y equals 0. So 0 equals 1 over x plus 1 minus 2. All right, so what should we do first? Add 2. Okay, so 2 equals 1 over x plus 1. What's next? Multiply by x plus 1. Okay, equals 1. And what's the next thing? Divide by 2. X plus 1 equals 1/2. And the last thing?
Add 1 plus 1. I mean, yeah.
Subtract 1. So minus 1/2. So there's going to be another point at minus 1/2, 0. Okay, graph it. So you have everything you need to graph this function. All right, let's start. Let's start with Snow. What is the transformation? Give me one. Right, 4, and then Kara is the other one. Uh-huh. Matt, what is the domain?
Which one?
The practice one.
X does not equal 4.
Mm-hmm. Jeff, range?
X doesn't equal 6.
Oh, not x?
Or Y doesn't equal 6.
Yeah. Okay, Alan, x-intercept.
23 over 6, 0.
Good. And then Brooklyn, y-intercept.
0, 20. Oops. Did the wrong one.
Okay. Or can you give me the vertical asymptote then?
Yeah, y equals 6.
Vertical.
X equals, wait, no. X equals 4.
Uh-huh. Okay, Jackson, y-intercept.
22 over 4.
Not 22 over.
23.
Yeah, 23. Okay, and then Nick, horizontal asymptote.
Y equals 6.
Yeah. Okay, so let's go ahead and graph this. X equals 4, y equals 6, and we have our points at 23 and as 23 over 6 for x-intercept, so that's a little less than 4. Y-intercept is 23 over 4, so a little less than 6. So the graph looks like this, and there's another part up there. All right, now we're going to go backwards. So they tell you that this graph is 2 over x. What is the equation of the function? So if this is 2 over x, then what we're going to do is we're going to use the asymptote that you see in the graph to tell you the transformation. Okay, so let's go ahead and write some equations for these asymptotes. What is the vertical asymptote equation? X equals, good, -3. And then what is the horizontal asymptote? Y equals 4. So that tells me that I move this graph left 3, up 4. The graph moved left 3, up 4. So then what do I have to do to change 2 over x to model that? So how do I write this equation so it's left 3? Plus 3 here. Okay? And then up 4, plus 4 on the outside. So then y equals that. That's it. So you want to just identify where the asymptotes are. That tells you where the transformation is, and then put the numbers in. Okay, so let's have you practice. So this one is a little different because now it's in 2 and 4, but we still want to just write the equation first. This is x equals 1, this is y equals 2. That tells me write 1 up 2. So if I didn't care about the reflection, I would just write x minus 1 plus 2. But since there's a reflection, remember if there's a reflection over the x-axis, we put a negative on the outside of the function, so that's going to be there. Okay, that's it. So a lot of you are putting a lot of negatives everywhere. That's not going to help. So only on the outside of the function. All right, last one. What is the graph of this? That's kind of weird. We've never seen that. We didn't really learn that in this section. So what did we learn in this section? Okay, so what is the parent function we learned in this section? 1 over x. So the question is it possible for us to change this equation into something with 1 over x? Maybe. So let's go ahead and try that. So xy plus 5 equals 0. Okay, what should we do first to maybe solve it for y? Okay, too fast. So minus 5 first. Okay, xy equals minus 5. And then what should I do to solve for just y? Okay, divide by x. So y equals negative 5 over x. Now it looks just like 1 over x. So you're going to now analyze this equation. Okay, let's start with Aiden. What is the domain? Aaron, what is the range? Jiwon, where is the vertical asymptote?
X equals to 0.
And then Isaiah, horizontal asymptote. Yes, good.